tried it the other day and it didn't work. Now it's working. Okay, so tell me what we're interested in talking about.
So I've only had time to go through chapter 5 and 6 to
Yes,
look at questions. I haven't had a chance to go back through the 7 and 8 PowerPoint yet,
that's no problem.
but
Let's see. Let me pull or get the PowerPoints in question. Okay, so what do you want to discuss first? 5 and 6 really should be the crux of the matter. I mean, 7 and 8 is just exactly the same as we did in the lab. But I mean, we'll still go over it if you have any questions.
so 7 and 8, you said it's just the same as lab, just identifying the
I use the
parts?
same list. I make sure that they match up so that we don't have any disconnect. And it's just going to be drawings like that skull model you saw, and of different bones, and use multiple choice.
Okay, so that should be easy for the most part then.
Yes, ma'am. Absolutely. Now,
So
6 has got a lot in it. 5, not so much, but whatever.
So one of the questions that I had was on the chapter 5 PowerPoint on slide 5.1.04a.
5.10.
It says,
1048,
yes.
the metabolic function. Okay.
Yeah,
Let
it said
me,
something about chemical conversions of carcinogens and some hormones.
I need to share this with you so we can both see the same thing. And there's my share thing. Okay. Okay. Are you able to see the
Yeah, I can see it.
PowerPoint now? Okay.
Mm-hmm.
So what happens is vitamin D is something that we naturally make in the skin and it takes like 20 minutes of sunlight per day to do that.
Okay.
There is some dissipation of carcinogens that also takes place in there, and some hormones, but nothing that we need to focus on. The main thing for the metabolic functions is going to be the vitamin D.
Okay. So don't worry too much about the carcinogens and hormones.
No, because really that's going to be like an AMP2 topic.
Okay.
We always seem to be getting into this, but it happens like that. Okay. What else on 5 are you interested in?
I didn't write down the slide for this one, but it talked about the blood reservoir in up to 5% of body's blood volume. That one.
Yes, we'll get into more on this in AMP2, but up to 5% of the total blood volume is going to be in the skin at any given time. And of course, that depends on the weather. If it's cold, we're going to have less blood because we're trying to conserve heat. And if it's hot, we're going to go to the max so that we can dissipate heat. And that's all that this is saying. The skin is the main way that we get rid of our heat. Dogs and other animals can't, but we use our sweat glands. And for the sweat glands to work, we need to have heat to activate them. So that's why we open up the blood vessels and let all that blood flow very close to where the epidermis is. And that way the sweat glands can absorb that, put their water on the surface of the skin, and then the excess heat is going to help us to convert it to a gas and let it vaporize off.
Okay. And then,
Mm-hmm.
sorry, I'm reading my list.
You take your time. We got a long time. Just
For the skin layer, the stratum basal, or however you pronounce that,
mm-hmm.
do we need to know the, in parentheses, the stratum germativum?
No. That's just an alternate name. And
Okay.
to be honest with you, I don't know anyone who actually uses that name on
So
a
it wouldn't be
regular
like on the
basis.
test.
We'll just use basal,
Okay. I just wanted to
which
make
I
sure it didn't
guess
like
is
pop up
maybe a
on the
French
test.
or Latin name. Just think basal layer.
Mm-hmm. Yeah, I'm familiar
That's
with
really what we're saying on that.
that one, just the however you say that. I wasn't super familiar with that.
Yeah, germanativium. It means the same thing. This is where we actually do the cell division. It provides all the cells to work their way to the top and then slow off.
Okay. And then the flexure lines, is that the same as the lines that the surgeons cut with?
No, those are tension lines. The flexure
Tension.
lines are just where we bend our elbow. That line you see when you flex your elbow, that line that allows it. And the same thing with the the popliteal region behind the knee and the inguinal region where the leg actually connects to the torso. Those are flexure lines.
Okay.
Oh, we also have one, of course, on the wrist.
So just basically know where those are.
Just know what they are.
Okay.
That's really all that you need to know on that one.
Okay. And then on the slide that talks about frank baldness,
Talks about who?
the frank baldness or true baldness.
Oh, you're talking about alopecia and baldness.
Yes. So in class, I wrote down in parentheses mother's father next to that. Could you go over that again?
Male pattern baldness is comes from the maternal side, and of course, it's going to be carried on the X chromosome. That's why it really comes from your maternal grandfather. But let's see if I can find it. Oh, here we are. So that's what's going to go on with that. It's just a matter of coming from your grandfather. Now, there's also another type that is caused by excessive testosterone. If you see a guy has a bass voice rather than a tenor, you can just about imagine that he's going to eventually get skin because the testosterone turns into that DHT, and that's
Yeah.
toxic to the hair follicles. There's
So take,
the true baldness. Alopecia is just the thinning of hair, and that happens in both genders.
mm-hmm.
And of course, there are other causes too, chemo and all that stuff. But as far as naturally occurring, that's really some of the only ones that I can think of is
Okay.
those two.
Perfect. And then let's see. There's a slide that has the burns on it, and it's listed
Oh
as
yeah.
1, 2A, 2B, and then 3 and 4. This
We won't. Yeah, we won't divide them like that. We'll just have one sunburn or like being scalded by hot water. Red, very painful because the nerves are
mm-hmm.
intact. 2, it's going to be deeper, and this is the one where you can get the blisters on it. And then
Okay.
3, which is going to be full depth, it's going to go almost to the bottom of the dermis or even to the top of the hypodermis. It's going to take out the nerve, so it's going to be painless, but this guy's definitely going to have skin grafts because,
Yep.
you know, that's just too much. And then
My
anything
sis
above that, hmm?
my sister had a really bad burn on her hand and they had to put fish scales on it.
Yep. Animal epidermis is good. Of course, human epidermis is better. And if they can do a graft from somewhere else on your body, like the thighs, that is the absolute best because nothing is going to protect you from the bad guys like skin. It's the ideal stuff. But
Yeah.
4, 5, and 6 is just going to be increasingly deeper. And I think that other one that I have over here,
Yeah, you have 1 through 4 on the slides.
I think that's actually a 6th-degree burn right there because there's nothing left on that guy's right side of his head, but the skull itself. But yeah, those are yeah, he's had a bad day.
Yeah. But
Hope
for the
he's
test
knocked out.
purposes, we would just need to know like 1, 2, 3, and 4.
Yeah, just know 4 is going to be way deeper. You know, you and I are never going to see these guys in the hospital. These guys are going to Augustus and the burn center. They
Right.
need highly specialized care. This guy's going to dehydrate because he's going to lose fluid, and then he's going to be a sucker for Pseudomonas infection.
Mm-hmm.
Okay. I guess you want to talk about skin cancers next?
Yeah, we can.
Yes, ma'am. So the 3 most common and going from least to most malignant, the basal cell carcinoma. A lot of people spend a lot of time in the sun, and my mom told me get out there and play in the sun because at that time that's what they thought was right. Unfortunately, all that exposure, and especially if you have sunburns, the more sunburns you have, the more likely it is that one of these is going to happen. Especially people who like go out on the boats in the summertime, and that water reflects the light
Mm-hmm.
up and kind of magnifies its intensity. But basal cells, most common, usually it's going to be on the face, someplace that's, you know, commonly exposed to sunlight. I always think of that pearly sheen. That's usually kind of what we see. The biopsy is actually the cure for it. They take a punch biopsy and just kind of twist it around. It's got a cutting edge on the bottom, and we get it out. Squamous cell is next up. You're going to see that ulcerated surface there, very common. And again, it's going to be on the things that are exposed to the sun. Can be raised or crusty or scaly. They have several ways of doing that. They try the Mohs surgery first, where they actually cut some, take it, freeze it, put it under a microscope, see if they got it cleared. If not, they go back and take a little bit more. But if it goes further than that, yeah, you can take radiation for that. It's possible to metastasize, but so it definitely needs to be taken care of. And then, of course, the granddaddy of them all, the melanomas, which come from the melanocytes. The basal cells come from obviously the stratum basale. The squamous come from the spinosum, and the melanomas. These guys are very metastatic. They can metastasize to the brain, to the liver, to the lungs. A lot of people are diagnosed, and a lot of people die from these. So this is something, and that's what we have on the next slide. I probably won't ask you about this. I might on the test, but this is something you want to know if you have older parents or friends or whatever. The characteristics, the A, B, C, D, E, the asymmetry is going to be very irregular. The borders are not going to be smooth. Even those are going to be irregular. Colors, multicolored, a lot of blue, brown, black. Going to be larger than a pencil eraser, and the key is it's changing fast. That's why
So
if
would
you
you,
got any kind of modes, and almost everybody does,
yeah.
you know, dermatologists are going to photograph them and check them over time, because this one will definitely take you out.
So with the moles and the skin cancer, would images be on our test for this or just
Oh,
questions about them?
no, ma'am.
Okay.
About the only images I use are going to be the ones for the bones. The skin,
Okay.
I might have a diagram. Let's see if I can find one that looks pretty. I mean, it won't be a color diagram. I might have something like that, but we did that in the lab. So I tend to focus on things we don't do in the lab when we're in the lecture class.
Okay. With the rule of nines, do we just need to know what that is, or do we need to know what each percentage goes to?
Just know it's a method of classifying the burns, and that each degree of burn has a critical threshold. So we go back there and look at, let's see.
I know, like
First degree, not a whole lot, like
the fourth.
25% is going to be dangerous, but with a third degree, only 10%. So that's
Yeah.
really just like one arm, or, well, that's it. About one arm is enough to make it a problem. The more surface area you have uncovered and open to bacterial invasion, the more critical it becomes. But again, if you have someone in that kind of shape, we're just going to stabilize them and get a light flight out to the burn center, as this is a job for experts.
Okay. All right.
Anything else on the?
I think that's all I had.
Okay. Well, let me stop this one, and I'll just go ahead and pull up number 6 and share it. You know, we
Yeah,
can
I have
see
a
if
couple of
there's
questions on that one.
Yeah, that one is a little bit different.
Yeah, it's a
Let's
lot to
see.
digest.
Yes, ma'am, it is. I understand. Okay, see this okay?
I don't see anything yet.
Oh, well, let me make sure that I actually shared it. Share content, Google. Oh, there's another button I had to press. Okay.
Okay, I see it now.
Anything specific on this?
The osteogenic layer.
Osteogenesis?
I don't know. I put osteogenic layer. Is that something?
Let's go to osteogenesis. Now, are we talking about prepartum or postpartum? Because there's, I mean, the formation in the womb or growth after birth.
Well, probably all of the above, because all I put was
Okay.
touch on the osteogenic layer.
Yes.
Okay. I understand. It's kind of complicated, and I wish I could find. Okay.
So I had another question on slide 6.2.5. So I'm assuming before that.
Let's see. 625.
That was my next question on that slide. So I'm assuming I saw something about osteogenic prior to that.
Okay, here's 6205A. That's about the red marrow. B is just showing how it's converted into yellow marrow. As you become an adult and you don't need to make quite so many blood cells, since we've stopped growing, we use that space for nutrient storage rather than that. Of course, as I told you guys, if for whatever reason you get anemic, we can convert that back into blood production.
So basically for that, just know as a child, it's red marrow, but as you age, it turns into yellow.
Yeah, because all you and I have to do is just replace what's been lost, what's been taken out because of damage or senescence. But the babies and the children and even the adolescents, they're still growing. They only have to replace what they've lost. They actually have to keep getting ahead more and more to support their growth.
Okay.
Okay, let's see. Osteogenesis. Okay. The prenatal, or not prenatal, prepartum, antepartum, as they like to say, starts around the second month. Remember that in the baby, everything's basically going to start out as total cartilage, with the exception of the collarbone and the skull, which is going to be membranes. We're going to have to turn most of that into bone before the baby's born. There's still a remnant, that fontanelle, the soft spot on the baby's head, and the bones are not quite completely fused together. That's why babies actually have more bones than we do, because theirs are still in the process. Okay, the two antepartum are going to be intramembranous. We're just changing those membranes into bones, the collarbones and the cranial bones. And then the endochondral is where we're actually breaking down the hyaline cartilage and changing it into bone tissue. Let's see, what's the take-home message on this one? The mesenchymal cells, which are the stem cells for all the connective tissue. These guys are going to turn into the osteogenic cells, the osteogenic progenitor cells. And these guys will then become the osteoblast, which are going to lay down this. And the osteoblast, all they do is lay down the fibers, the collagen fibers, and they lay them down, as we said, in alternating directions with each layer. And then the osteocytes are going to release a hormone or a chemical that's going to cause the calcium and the phosphate to condense on that and kind of coat those fibers with some very stiff and hard crystals. Trabeculae are going to be formed. They're going to connect to each other, and they're going to make the spongy bone. The mesenchyme, again, it's for all the connective tissues, going to form that dense, regular periosteum. And the outermost are going to become the compact bones. Okay, these guys, and again, this part is just for our membranes. And you can see this, you're not going to see this on the test, but there's the mesenchymal cells. Those pink things are those trabeculae, those struts, blood vessels, and then you've got the osteoblast. Let's see. Well, this thing could be larger. Well, then I've got this thing in the way. Let's close that.
This
Okay,
stuff
you
is
go
just
to that.
so confusing.
Yeah, there's the mesenchymal cells, and they're developing into the osteocytes. The osteoblast, the osteoid tissue are going to be right on that mesenchymal. The osteoblasts, the first ones are going to get surrounded, and they'll develop into osteocytes. And these guys are basically going to do the spongy bone, which is going to be the majority of the bone anyway. And these guys are going to connect, I wouldn't say in a random fashion, but since the baby is floating in fluid, it's probably not a lot of stress. So but by the time they need to use their bones, they'll be remodeled. And they're going to put this out there, and then eventually they'll get that that collar around it of the compact bone. And it's basically the same process. And we saw how that kind of grew up and surrounded a blood vessel. And later on, they built layers to make an osteon. Okay, the endochondral, which is going to be the majority of it, the cartilage is already in the right shape. So all we need to do is to establish ossification centers. Usually they put them on either one of the epiphysis, and there's one in the middle, kind of starting there. That's the primary. The ones in the epiphysis are going to be secondary.
And what is that? What was that?
Yeah, let me show you. There's the cartilage model. And the cartilage is going to eventually calcify, but that's not bone. So then we have a primary ossification center right here, right around the middle, the shaft of the bone. And in this place, we're going to be tearing down the cartilage, and the osteoblasts are going to lay down the fibers that are going to get coated. And then at a certain point, we're going to have these secondary ossification centers, but they're going to be on the epiphysis, the ends of the bones. So these guys are kind of going to grow. The primary is going to take care of the shaft. The secondaries are going to do the epiphysis, but we're going to leave that big, or that not so big, whatever, that line of cartilage, because remember, that's what's going to be used to grow after we're born. Does that kind of make sense?
I think so, but I don't know. I
Well,
think so.
we got cartilage. We're going to replace it with bone. We start on the shaft first,
Okay.
but we can't let the shaft go all the way to the ends, because if we do, there's going to be no way for our bones to get bigger after we're born.
Mm-hmm.
So to get around that, this primary center is only going to do the shaft. The secondary center is only going to do the ends, and in between them, we're going to leave that line, that plate of cartilage, so that they can grow after we're born. That's kind of basically what's going on with this guy.
Okay.
It's not really that complicated, and especially.
Well, when you said it that time, that made a little more sense.
Yeah, it takes a little bit of time for this to sink in. The chondrocytes and chondroblasts in the cartilage are going to actually do apoptosis. They're going to die as per program, and then the other guys are going to come in. The osteoblasts, remember, cartilage doesn't have a good blood supply. The osteoblasts are going to release factors that causes blood vessel growth. They call that angiogenesis. And then they're going to go in and do that. This is a really good one. I think this one is maybe even a better one to show you how that collar forms and the cartilage is dying, and we eventually get in there, make all that spongy bone, bring it out to the ends, connect up with that initial, and then these secondary centers start developing. But we got to leave both of these ends unconnected so that we can grow our bones after we're born.
Okay.
Does that make more sense? Maybe?
Yeah. And then before we go any further, I
Yes,
had, I guess, all of slide 6.2.6H. I was confused on the whole thing.
6.2.68. Okay,
H.
that's
Yeah.
6.2. Well, I don't have a 6.208.
No,
I may have a
6.2.6H as in
oh
Henry.
6H. I'm sorry.
It's
This
okay.
guy right here. Yeah, and I've got a better picture on this, but basically what happens is these are the osteoclasts. They're really just a bunch of macrophages that kind of merge together and they make this big multinucleated giant cell. This guy is going to be the one who breaks down the bones when our calcium levels go low, or when we're remodeling because we're suddenly doing something different and we need our bones to be stronger in a different direction. These guys have got a little, it's kind of like a skirt that covers where they're about to release all those nasty acids and all this stuff that's going to dissolve things. And then they produce hydrogen ions, in other words, acid. And they're going to produce some things to break down those fibers, the collagen that the osteoblast did. So the acid is going to dissolve the calcium phosphate crystals, and they're just going to be calcium and phosphate, and they're going to be released back into the circulation. The collagen is going to break, or the collagenase is going to break down the fibers and release the amino acids back in the circulation. This guy where they do this is called the ruffle zone, but it's really just like a skirt. So let me see. Let me get my pen. So here's what they do. So they land. They want to take out this area, so they put their skirt around here so that those nasty chemicals can't leak out and damage something unintentionally. And you know, that kind of makes sense too. What do you think?
I don't know. I just feel like there are so many slides about osteoclasts that there's just so much to those things.
I think I got a better one coming up though. We'll look and see what we've got.
So what would you say is like some of the most important things about osteoclasts?
That they're controlled by the osteocytes, which take their clue from a hormone released by the parathyroid. You don't need to know that. By a hormone that is released when your blood calcium levels are low. So most of our calcium is tied up in our bones. We haven't got there yet, but we have to have calcium to make our muscles move, to make our heart beat, to make our brain work. So calcium is super important. And the osteoclasts are just giant macrophages, monocytes. These are big cells that break things down. And they actually, one of their main jobs is just swallowing bad guys that get in. Okay, let's see. Yeah, this might be the very best slide to study from.
Yeah, I'll go back over that one.
This one's pretty good. I put several on there so that I could find one. Okay, so we talked about intermembranous and then the endochondral ossification. That's before birth.
Mm-hmm.
Now, postnatal, our bones are only going to grow in two directions, right? They're going to grow longer and they're going to grow wider. That's it. Appositional growth, which is where they get longer. And if you remember, we saw those tree-like rings in the osteon. And
do you mean that they get thicker? for appositional?
Yep, we just lay down a new layer of bone on the outside of what we already have, just like a tree grows. So those rings on the osteons are really growth rings, just like they are in a tree.
Okay.
So these guys are on the periosteum and they're facing the bone. So the osteoblast, all they have to do is just lay down the layer and let it get calcified, and voila, they're done. And of course, there is a time when they will cut off. But appositional growth is super easy. It's just, you're just going to lay down a layer on top of what you have. That sound pretty reasonable?
I think so.
Okay. Now, the other one is a little bit more involved. This is why we had to leave those cartilage plates in there, because we're going to use those to make the bones longer. And that's the interstitial growth. And basically what we're going to do, that cartilage is going to grow out. So what it's basically going to do is move the head of the bone away from the shaft of the bone. How's that?
Okay.
Now, after it does that, what's going to happen is the cartilage on nearest the shaft is going to be converted into bone. So we go back. And so this guy pushes it out. This guy comes right behind him. And this continues until they get to the point where the genes say that's as tall as this person's going to be. And then they stop.
Okay. And then what
And
about, or
yes,
so what about the bone regrowth? Is that the same thing as growth?
No, not really. Because once these epiphyseal plates are finished, they're done. They'll stop, and eventually they'll turn into bone too. They'll actually go away. And if for whatever reason they close early, that's just too bad. The person's arms and legs will be abnormally short, where their torso will be a normal size. But bone growth or regrowth after a fracture is a little bit different. Okay, here's probably the most complicated thing about this. So you got that resting zone at the very top. So this is where the epiphysis, the end of the bone is, okay? I still got my pen. I do, wow. So that guy is resting. He's not doing anything. This guy is the one who's continuing to grow, and he's pushing this guy away from the shaft. Okay, behind him, the cartilage cells are actually getting bigger, and they're getting ready to die. That's the hypertrophic. It just means it's getting bigger, large, huge. And you can see the difference between some of these guys and this guy right there. He's huge. And number 4, right here, we're going to see the cartilage cells are dying. And as they die, the whole area is becoming calcified, but it's still not bone. It's just calcified cartilage. So over here, at the very last, this is where bone is. We're going to have the osteogenic cells, the osteoblast, are going to lay down the fibers, and they're going to get calcified, and they're actually going to become bone. This is maybe a little easier to see than that photo micrograph. Don't worry about that pre-hypertrophic. It's nonsense. We just going to use these proliferative, hypertrophic, the calcified, which is the dead zone, and then the ossification. And I think I got another one. Same thing, proliferation, they're growing, hypertrophic, they're getting huge, they're dying, And then the osteoblasts are coming in. You're going to have some osteoclasts too. They're going to break down the dead calcified cartilage and replace it with fibers and then bone.
So would it be wise to know the difference in all of these layers?
I think so. That may be what you were talking about when you were talking about the osteogenesis layers.
It may
And
be,
we
I
can
don't
go
know.
over this. I mean, it's no problem. It does take a minute to get your head wrapped around this.
Yeah, it really does. So would
Mhm.
a question about one of these you think be on the test?
Well, you need to know in general how the interstitial growth goes. You need to know that the cartilage expands, pushes the epiphysis away from the shaft, and that as it does so, the ones that, this was the proliferative zone before, these guys are going to get big, and then they're going to die, and then we're just going to replace them with that. Sometimes when they make a road, they'll get the bulldozers, they'll make a dirt road, and then sometimes they'll put those little rocks and gravel and tar on there, but then they're going to come later and put blacktop on the road. So it's like a stage of developing. Does that make sense?
A little bit,
Sometimes
yeah.
you start with just a dirt road, but eventually you want to have it paved. But you got to have the dirt road first. You can't pave the thing that hadn't been bulldozed.
Right.
Okay. And that's just showing there's the closed epiphyseal plate. At some point, the genes are going to stop. It's going to stop the growth, and this guy's going to close. And that's as big as we get. There's the appositional growth. There's really not a lot to that part. Now, here's how we get those the osteons. So you got these arteries, that's eventually going to become the central artery. Well, of course, they're saying that's the perforating. No, that's perforating canal. So this must be the central artery. I don't know. In any case, basically the bone just grows around it. And after it surrounds it, like here, they just lay down those layers of the bone until this guy's, he has a much smaller opening. Let's see. Here
So
shows a little.
on the bottom of this picture where it says B, it says a bone grows in diameter as new bone is added to the outer surface. At the same time, osteoclasts reabsorb bone on the inside.
Mm-hmm. Yeah, you remember we were talking about, so if you want to grow in width, you just put another layer down. But as you grow, then this hole is going to get a little bit bigger. Now this is a single osteon. This is an entire bone shaft. Does that make sense? These are two totally different things.
So the bottom is entire bone shaft. The top is one
Yeah,
single
it's
osteon.
not just that's just showing you how an osteon forms. But when it puts it down, we're gonna have spongy bone in here, and this is kind of not a good thing. The spongy bone is going to be all in there. It's not actually empty space, but that's where the medullary cavity in our bone marrow will be.
So you're losing the compact bone, but you get the spongy bone on the inside?
Yeah, I think that would be a good way of saying that. On the outside, you need spongy bone. You need compact bone. So as we add compact bone on the outside, we take out the one on the inside and replace it with spongy bone because it's lighter, and we want our bones to be as light as possible and still be strong enough.
Okay, that makes a little more sense.
Okay. Let's see. Bone growth hormone, and thyroid hormone work hand in glove. Estrogen and testosterone, that's why at puberty, the kids just zoom up. There are some vitamins you have to have in order to make bones. You're going to have vitamin A and vitamin C. Vitamin C is for the collagen. Of course, if you have too much vitamin A, it's also toxic. We talked about this. I don't really expect you guys to know a whole lot about this. We got an entire chapter in AMP2 dealing with hormones. But just know a hormone is what actually stimulates bone breakdown. Calcitonin doesn't really do anything in humans. It does not. It's a very poor. It's not nearly as potent as this guy. And of course, vitamin D that we made in our skin, we need that so that we can get calcium in through our GI tract to put it in the blood. And its pathway is kind of complicated. It actually, vitamin D is made in the skin. The kidneys are what turns it into the active form, 125 vitamin D. Calcitriol, I think is its name. But we don't need to know any of that. It's just kind of hopefully filling in any blanks. Okay, here comes the part that you were asking about, fracture repair. Well, this one is really more about bone remodeling, not because of fracture, but because a change. Children are getting bigger, they're getting heavier, and their bones have to adjust. They don't have the growth hormone to do it, but the way the growth hormone is used to put more bone on is going to depend on the stresses on the bone. And like I said, we know this guy goes in the acetabulum, and that's just really weird to have a bone like that. That doesn't seem very sturdy, but so most of the force is going, that makes sense. Most of the force is going down on the inside and a little on the outside. So what they're going to do is take some of the bone off here and put more on here, and it would actually shift the force over. The only thing you need to know is the stress on the bones are going to cause the remodeling. And that's what we had said. Okay. Osteoclast, old bone, they break it up. New bone is laid down in the area that needs it. We talked about all of that. Well, vitamin C, vitamin D for the absorption. Vitamin A, the calcium, got to have phosphate because that's going to be part of it too. The osteoid seam is just a part of the matrix that has not been crystallized yet. The calcification front is between the part that has been calcified and the part that hasn't. It's really something like this. That's the osteoid seam because it has no crystals. This has been crystallized, and this is the direction that would be the osteo or the calcification front. Excuse me.
So with this chapter being super long and super complicated, what would you say are some of the major things to pinpoint focus on to help study better before the test?
Well, I think some of the ones you've asked about have been right on the money. This, not so much. It's interesting, but it's really more than we need. Here's a picture showing what I tried to illustrate. Here's that much better picture of the osteoclasts at work. You can see these guys releasing all this stuff, and they're actually going to dissolve that bone, the crystals and the collagen. Hormonal mechanisms, that's we take out away from our bone when we need calcium. And then also, what are you doing with your bones? You know, if you're taking up a new sport or you have a new job that requires different movements, your bones have to remodel to account for that. We already talked about that. That's okay. Calcium homeostasis, we've talked about that. You don't have to go into a whole lot of detail. You just need to know that we use our bones to store calcium, and we make a withdrawal whenever we need them. Okay. The mechanical stress that we talked about actually has a name. And, you know, they like to put this kind of stuff on the test bank questions. It's just Wolff's Law that the way you use your body is going to determine how your bones are actually structured. And the right and the left-handed is, you know, I'm right-handed, so my right hand, right bones, right muscles are bigger than the left because I use it more. It's just, and it's really kind of common sense. The bones are going to be thickest where they're in danger, and we saw with the clavicle, that's the place where they mostly break, probably about a little bit further over this way. And so that's the place where it's going to be more thicker. And, you know, you saw on the tibia, you got that big tuberosity because of those whopping big muscles attaching to it. The trabeculae, the exact orientation of those trabeculae is going to be according to the stress you put on your bone. And we already talked about that with the tuberosity. So what the ideal thing is, with this thing being pushed down, it would tend to tear the bone on this side and squeeze it together on this side. But it's going to be okay because these two things are exactly the same amount of force, so they basically cancel each other out. And so our femur doesn't break, which is a really good thing, unless you got osteoporosis in later years. The bone fractures, we had this on the lab test. Displaced is when these guys are no longer aligned, non-displaced. They're broken, but they're still, you know, in the same line that they should be. Complete and incomplete, that's kind of self-evident. Linear or transverse. Linear is when it breaks in the long ways. Transverse is when it breaks across it. Compound, simple, open or closed. Compound is when the bone breaks and it actually sticks out of the skin. And simple or closed is when it's still in there. And okay. Comminuted is going to be one of those where you get several pieces. This is more than just two pieces. You can see it on that fragment. That's just awful. Compression fracture is just osteoporosis, bone thinning, just the normal body weight eventually is going to crush those. And you see a lot of people with that from the hospitals or from the nursing homes. This is a spiral fracture because it's kind of broken at an angle and transversely. Epiphyseal, that would be bad. I don't think I've ever seen anybody with that. I hope I never do. But that actually breaks along the epiphyseal plate.
I think that would be the easiest one to remember.
Yeah. Depression fracture, if you get hit on the skull and you break the bone, it's going to be pushed inward. And then the green stick, I think that's the easiest one because I used to play with sticks a lot when I was a kid, and you get those green ones and they don't want to break.
Yeah.
You have to solve those guys. As far as the stages, first thing we're going to do is we're going to bleed in there, and we're going to basically form a blood clot to try to keep things more or less together. Obviously, this isn't a real strong thing, but it serves the purpose immediately. After that, then we're going to have some fibroblast and chondroblast come in, and they're going to make a callus, which is basically just a bridge between the two bone ends that are going to be partly fiber and partly cartilage. Eventually, these guys, just like in bone growth, are going to be replaced by spongy bone. And that's what's going to heal. The bone is going to heal as spongy bone. Now, you can see over here, this bone end is way too big on both sides. So it could be up to 2 years before this thing remodels itself back to its normal thing. And even then, you're always going to be able to see on x-ray that fracture line. That's why I was telling you guys, that's how you can catch child abusers in the hospital. That's why a lot of times they don't want to bring their kids to the hospital. And that in itself is suspicious. This is basically the same thing, just a little bit more explicit. Broken bones hurt a lot. The cartilage, the fibroblast, the phagocytes going in there, getting rid of everything, the bony callus, and then the remodeling. And here's just another picture of it. This is a really good one, I think. You can see the blood clot and then the fibers and the cartilage trying to form a little bit more solid bridge between these. And finally, the spongy bone in there, which later on will be replaced. And the spongy bone on the outside will become compact, the spongy bone on the inside, because once it's in a cast, you're not going to be moving it. But once you get it out and start using it, the spongy bone will remodel to suit what you're doing. That's pretty straightforward and simple, I think.
Yeah.
Flat bones, think sternum, skull, ribs, flat and curved. Long bones, we already said, it's not how actually long they are, as long as they're longer than they are wide. Short bones are like cubes. Irregular bones are like the vertebrae. And sesamoid look like little seeds. Of course, patellar is a little bit bigger.
And so the sesamoid bones, they grow in tendons, correct?
Yeah. And as I say, we have 2 small ones right before our thumbs and 2 small ones right before the hallux. Okay. Bone markings, we did that in the lecture. I'm not real hot dog on doing that in here. I mean, the specific bone markings we need from chapter 7 and 8, but by now, hopefully everybody already understands this. That's all of 6, ma'am.
And then so for 7A, it's basically the same as lab, just identifying, like the part of whatever the bone is.
Yeah, let me pull those up and okay, let's see.
And then also, just because I'm dying to know, when will our midterms be graded?
Well, I'm actually still grading AMP2s.
No.
I will get on it. It'll be Saturday, Sunday. It ta well, I can't put this in a Scantron and have it done in 5 minutes. I have to go over each one at a time, and then I got to make a judgment call. Is that close enough for a half a point? So it takes a little while longer when you have to, when you give partial credit.
I
Plus,
understand, but the
I
anxiousness in
know
me.
everybody's anxious. And I don't blame you. I was the same way when I was in school.
So,
Okay, let me.
but you think it'll be this weekend?
Oh, yeah, I'm hoping I'll get it done this weekend and won't have to carry on into Monday because I've got an lecture test to do. Okay, the cranial bones, there's not really a lot. This is just the same old, same old. And again, all we're going to do is the exact same that we did on in the lab. And I definitely will not give you exploded bones like this in isolation. And if you see it, it's going to be as part of a structure you recognize.
Okay.
Maxilla, to be honest with you, I just don't see anything new in here. I don't usually test the sinuses in here. I usually do that in AMP2 when we do the respiratory.
But say like there's not going to be questions about the bone, it's just identifying the bone.
You may have to identify marks on the bones like trabeculae or trochanter.
No, I get that. I meant, but you're not going to
Oh,
ask like a particular question about the bone other than labeling parts of it.
yeah. That's why I'm looking through here to see if there's anything I really need to bring out. We did
Okay.
this in the lab. I didn't actually have those questions, but we did that about the curvatures and all that. Kyphosis,
Okay.
lordosis, and scoliosis. Actually, I have a friend that has that. It's very painful. Or it's
Yeah,
a
I need to
child,
check on
rather.
those because I'm not super familiar with those.
Oh, it's just the curvature of the spine is abnormal. If it
Hmm.
curves to the left or right, it's scoliosis. And, when you're expected, you arch your back to try to maintain your balance. Kyphosis is something you see in a lot of elderly women, and I suspect it's due to compression fractures, but we did all of this. Not a lot on disc herniation in here. Vertebrae is the same as we've done in the lab.
So
Oh,
will there be questions about herniations?
mm-mm. But here's
Okay.
some things that you want to know about, and this is the clinical part. And this is probably the most important thing for most of you guys to know going to work in the real world. Osteomalacia is when you don't have enough calcium, so your bones are not as hard as they're going to be. And so you get this bow-leggedness is characteristic. In adults, we call it osteomalacia. In children, it's called rickets. Because of that bowing, you can actually put more stress on it, and especially with less hardness, the bones will be more prone to break. I don't know what
Okay.
that's for.
Yeah.
Okay. Osteoporosis, we talked about that. That's usually going to be. It can happen in either gender, but it just petite postmenopausal females have a lot more of this, and it's just what we were said. When you're children, you lay down more bone than you take off. When you're an adult, you match it. But when you get older, you start taking more bone than you lay down. So obviously it gets thinner and weaker.
Hmm.
There's a really good picture to show what happens in osteoporosis. Bad, bad thing, a lot of problems. Paget's disease you lay down bone, but you lay down more, you don't lay down as much compact bone. And the trabecula, you remember I told you the spongy bone orients itself to stress? This guy doesn't. He just lays it down in a chaotic fashion. And so you get something like this where the bones are abnormally curved. And no one really has a good handle on that. We talked about this in the joint chapter, so I probably will wait till then to talk about osteoarthritis.
But that's the wear and tear one, right?
Yeah. Now, as far as dislocations, we talked about that, and I would prefer to do those with those. So we're not going to really do a whole lot with that. So let's go see chapter 8. I don't think there's a whole lot more.
So you said don't focus on dislocations right now?
Dislocations, arthritis, we'll do those when our next test, when we do the joints. That's really a better time for that.
Okay.
Okay, let's see. These guys, not a lot on here that we haven't already.
It's the same stuff as lab for this.
Yeah. Just want to make sure that I don't overlook anything. And what I really need folks to know is the female pelvis is wider and the sacrum doesn't curve up so far into it, and that's for child rearing. The male pelvis is narrow, but it's not, and you don't have to all that stuff.
So you said no, that the female pelvis is wider, and then what about childbirth?
For childbirth.
Just for childbirth?
Yeah, and if you were to look at the pelvis from the side, the sacrum in a man is going to curve way up in there, which obviously there's no baby coming through there. But in a female, it's going to be more outward. No, I said outward. Oh well, this thing has a mind of its own. But you get the point. So it's adapted for childbirth, and that kind of makes sense.
Okay.
Not a whole lot on this. Not a lot on that. We're doing the metatarsals. The arches of the foot, just know that normally our foot has an arch. Sometimes it's exaggerated, which is hollow foot. Sometimes it's really low, and that's what we call flat-footed. Those are the folks that can't get into the military or are able not to get into the military. Well, that's it, guys. Any other questions on anything?
I don't think so right now. I'm going to go look over a couple of things again about chapter 6 and try to watch a video or something just to help dig it into my brain.
Why don't you, if you can find one, I've been looking, see if you can find one on YouTube on especially interstitial growth postpartum. That would be great.
Interstitial growth postpartum?
Yeah, with all those zones of cartilage and bone coming up, that was something that's just screaming for good animation to make it more understandable.
Yeah.
But you can, if you come up with any questions, shoot me an email. I'll check my email, make sure, I catch it, and then I'll send you an answer back. So far, AMP2 has not asked for a WebEx, so aside from doing the grading, my weekend's open. So I'll keep a check on my email for you guys.
Okay, well, I appreciate it.
My pleasure, ma'am. Just let me know
Okay.
if there's anything else comes up. Miss Rosa, do you have any questions?
No, I think I'm good. Thank
Okay.
you.
And the same thing, just shoot me an email, guys, if you come up with any, and I can either send you an email, or if we have to, we'll set up another WebEx, even if it's just for you.
Okay. Well, thank
Okay.
you.
All right, guys, y'all
Thank
have a great rest of the weekend, and let me know if I can help you, okay?
Okay.
Okay. You
Bye.
too.
All right, see ya. Wait a minute, I gotta stop this. Okay.